I worked on the car crash data. This is basically like what I thought was like first initially I tried to predict the crash like for the future based on time. But since like the time series is going to be for the next project, I thought let me just do something else. So then I figured out after a few variations, I figured out like, okay, if it would be great if somebody can predict what kind of damages will cost them. So what I did is like I split it into two parts. One was like the damage cost, which will be more than $1,500, and the other one, which was less than $1,500. So that was the target variable which I worked on. So yeah, so the case was the cost which I wanted to work, and the database which I worked on was from the City of Chicago data website, and the data that was provided was between 2015 and 2020. Now, there are some interesting things that I found out while doing the exploratory data analysis. Right, one was like there were a lot of damages which were based on parked cars. So so most of the times it seems like where people were turning and then they were like they found that they did the wrong turn and then they found that the cars were parked and then they crashed into it. And this is just one of my assumption worked on that. But otherwise, there were a lot of car crash, right? If we say, right, the speed of the car, which if it was beyond 65 and above, the car crashes were very high. That was one thing. And when it comes to the weather condition, one interesting thing I found was, if you see the number 10 here, it was basically like when there are severe storms, the crashes were to the minimum. So people probably did not move at all. That was my assumption based on that. But otherwise, like when there were windy, when there's special storms that were there, the damages were right on the higher side. The direction part, not much when people arrive, when the cars were moving in different directions, there are not much of difference between whether you're moving in any direction. The car crash still happened. But then the cost of the crash has been increasing over the past 5 years. There is a steady increase that we can see. Now, the algorithm that I used was like after going through a lot of models, I shortlisted these four models: logistic regression, classification tree, naive-Bayes classifier, and KNN classifier. These were the models which after going through, because like for XGBoost and other things, like I found like it was taking too much time, and then I probably do not have the right kind of system. Maybe I'm just taking it for so maybe like I'll just work on that, increasing the database. Now after running through all the models, I found that the the most accurate or closest one was the logistic regression, because based on all the three uh, parameters, whether it's accuracy, precision, or recall, which I ran, logistic regression was the best I felt. But then if you see the decision tree, was pretty close to the thing. So so what I did was I ran both as two different notebooks. I tried both the models for the final mock part, and I've still had, I found that logistic regression was better in time. But I'm not sure. Once I maybe like I if I when I run through ish for the review, then maybe we can figure out like why it was getting into that part. So that was my final model which I used and then worked on. Next step, what I feel is like I would probably work on a larger data set, right? And I want to predict crashes, which is based on time. Like if you are traveling on a particular location and on a particular time, right? How likely you're going to get into a crash situation, right? So that's all from me. This are my links. Anybody who's wanting to just check on. Thank you.